A hexagonal pyramid of 25 mm sides of base and 50 mm axis length rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees. So here, since it is a hexagonal pyramid resting on one of its edges of the base, rests on HP on one of its edges of the base, so obviously we have to start from the horizontal plane. So you can see that we are starting from the horizontal plane. Since one of the edges is resting on HP, so the edge which rests on HP has to be perpendicular to VP. You can see this AF is the edge which is perpendicular to VP. So this AF is perpendicular to VP. So this AF is perpendicular to VP. And then he says, so when you look from the top view, we can see the hexagon totally. So since all the edges are resting on HP, so obviously that will going to be parallel to HP. Since all parallel to HP, so I can see the true length of HP. So in true length means what? That will going to be the side of the base, which is 25 mm side. So when you look from the front view, you can see the height of the pyramid, which is 50 mm. So you can see that height 50 mm here. So that is the one which has been written in the front view. When you look from the front view, I can see this AB, O, we can see OC, OBC, and we can also see OCD. So OAB, O dash, A dash, B dash, then we can see O dash, B dash, C dash, which you can see here. So that is the one which we have been shown here. Now the same thing which is been written in the orthographic view. So here we need to construct the hexagon such that the edge which is resting on HP has to be perpendicular to VP. So you can see the edge which is perpendicular to VP, one is AF and the other one is CD. So both the edges are perpendicular to VP. So in order to construct this hexagon, first consider, you draw a vertical line first, and then consider any point on that vertical line, and then with a radius of 25 mm, which is the hexagon. So with this as center, take a radius of 25 mm and draw a circle first. Once you draw the circle, so this circle will going to cut at the point, or going to get, when you draw a vertical line, so you're going to get that as the diameter, which is 50 mm. So you, from this point, you take a radius of 25 by using the compass, and you cut an arc on this circle, and similarly on this side also you cut an arc on that circle, and similarly from this point you cut an arc on this circle, and you cut an arc on this side of the circle. So we will going to get 6 points. So then join from this point to this, 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 and from this point to this, and to this point. So we will going to get a hexagon. The other method is draw a vertical and measure an included angle of 120 degree and then construct. That is also possible. So you name them, which is A, B, C, D, E, F. Then draw the diagonals, that is draw between BE, draw between AD, and draw between CEF. So all these three diagonals will going to meet at this point. So this point is going to be the center of the hexagon, wherein you are going to have O and O1. So when you look from the front view, top view, O is near to the observer, so it becomes visible, and O1 is away from the observer, it is just below that, so you are going to mark it as invisible. Similarly, when you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible, and DEF is away from the observer, so D dash, E dash, F dash is invisible. So now we need to write the front view. To write the front view, draw the XY line, and then you project these points to the XY line. And since you are looking from the front view, ABC, so you mark A dash, B dash, C dash, which is near to the observer, it is visible, and D dash, E dash, F dash is away from the observer, it becomes invisible. So all these things you put it in bracket. Then the height of the pyramid is seen. When you look from the front view, I can see the height. The height of the pyramid is 50 mm. So from here, measure a distance of 50 mm and mark this point. Then you mark that point as O dash, And similarly, when you look from the front view, ABC is heading that point O1, so the O1 dash will be invisible, so it will be in bracket. Then visible point to visible point is visible, so you dark this. Visible point to visible point is visible, so you dark this. Visible point to visible point is visible, so you dark this. So A dash, B dash, C dash all are visible, so you dark this. So you are going to get the triangle, which is going to be the front view. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees. Now here, since the axis is parallel to VP, that is OON is parallel to VP, so I am getting the true length here. But the inclination given is also true inclination. So since the axis is inclined at 45 degrees, so the base also has to be inclined at an angle of 45 degrees. So consider any point on the XY line and you mark that point as A dash, F dash. Then since both the edges are perpendicular to VP, either you can restrict on A dash, F dash, or you can restrict on C dash, D dash. If you restrict on C dash, D dash, then you have to rotate clockwise. Since I am resting it on A dash, F dash, so I have to rotate in anti-clockwise direction. So then from A dash, F dash, by using the protractor, you measure an angle of 45 degrees with respect to the XY line and then draw a inclined line. Then measure the length from A dash to C dash. From A dash, you cut an arc on this to get this point. So this point will going to become C dash, D dash. Similarly, you measure the distance from A dash to B dash. From A dash, you mark that point here to get this point B dash, A dash. Through this point, now we need to represent this one, or we need to draw this. So in order to draw this, so this O dash, B dash is perpendicular to this XY line. So from this B dash point, then you measure an angle of 90 degree with respect to that inclined line A dash, C dash, then draw a perpendicular line. Then measure the distance from B dash to O dash. From B dash, you cut an arc on this to get this point O dash. Then complete the second position front view exactly in similar of in the same as that of the first position front view. Now we need to write the top view. When you want to write the top view, so draw a vertical projector from O dash and draw a horizontal projector from O to get this point O. Similarly, draw a vertical projector from A dash, F dash and draw a horizontal projector from F and A to get these 2 points AF. Similarly, draw a vertical projection from B dash, D dash and O1 dash and draw a horizontal projector from D and draw a horizontal projector from O1 and draw a vertical horizontal projector from E to get these points B, O1 and E. Similarly, draw a vertical projector from C dash, D dash and draw a horizontal projector from C and also from D to get this point CD. So once you get all these points, then join them with a thin lines. Don't dark this and don't do dotted lines also now itself. Then join between A to B, B to C, C to D, D to E, E to F and F to A with a continuous thin lines. Then join between OA, OB, OC, OD, OE and OF. How do I know that we have to join like this? Because here you can see O dash A dash is joined, O dash B dash is joined, O dash C dash is joined, O dash D dash is invisible there, so it is not to be shown, but you have to join this OE and OF. You can see it is also evident from 3D also. All the vertices has been joined with respect to the apex with that inclined lines. So here, so once you draw this, now you are going to have the once you will be able to see the top view of the second position. So now we have to do the condition of visibility we have to apply. So how to apply that? Now we have a clarity here. There are the boundaries of the solid we have to see now. Which are the boundaries of the solid? OB, BC, CD, DE and OE. So this is the boundary. So all the exterior edges of the boundaries of the solids are visible. So this is the first condition of visibility. So you dark them OB, BC, CD, DE and OE all are on the boundary. So you dark them with the dark lines. Then with a dark line. Now when you look from the top view, so this is the top view, this is the front view. For this I need to write the top view. When you write the top view, you can see OCD is the triangular face which is near to the observer, so it is visible. So O dash, C dash, D dash is a triangular face which is visible. So because that is near to the observer, so CD is already visible, so I will go to dark this OD and OC with a dark line. Once you dark this, now we will going to see what happens to AE now. Since these two edges are visible, so naturally AF will becomes invisible, because the condition says two visible edges can never cross each other. So if AF becomes visible, then OD is already visible, so two visible edges becomes crossing each other, so that means it is not possible. So obviously this AF has to be invisible. Since A is not on the boundary, so naturally from that particular point, if any of the edges, if one of the edges is invisible or visible, then automatically that becomes the other edges emanating from that point will automatically becomes invisible or visible according to the same condition. So here, since AF is invisible, so AB becomes invisible and OA also becomes invisible. Similarly, since F is invisible, that is FA is invisible, so FE and OF becomes invisible. So what happens to the position of O1? Since in ABCDEF of a hexagonal surface, AB, AF and FE is invisible, so naturally O1 will going to become invisible. In other words, when you look from the top view, this triangular face OBC, OCD and ODE are the triangular faces which are visible, so that means it becomes an opaque surface. So naturally O1 is beneath that, so naturally O1 becomes invisible. In other words, if any one of the sides of that hexagonal surface becomes invisible, so naturally the O1 point will going to become invisible. So that is the reason why we put it in bracket.